Hello everyone. Today I will show you how to do single crystal data refinement using Olex. The data sets are already shared in the Google Classroom. You have to download this sucrose.html file, sucrose.res file. Once you download, you keep them in separate folder. These two files will be there. Here HKL file you can open in notepad, then you will get idea about first three columns are HKL indices. Third one is the structure factor, then fourth one is the ESD associated with given structure factor. So there are thousands of reflections and their corresponding data. Then in the other one, you go and open RES file. You can see all the details about unit cell space group. Space group is P21 here. Then the cell is there. Here 0.71 is the wavelength that is used in this experiment, that is molybdenum K alpha radiation. Then this is alpha A, B, C lattice parameter, alpha, beta, gamma. So by looking at this lattice parameter, you can say whether it is monoclinic or any other space group. The next row should be here Z is there. This you can edit actually. This should be 2. The reason is P21 has two formula units. Next, all these are standard deviation associated with given lattice parameters. This is a structure factor. There are carbon, hydrogen, oxygen atoms. Then how many least square refinement, all these things are there. You can keep as such. In the next one, I hope you already installed this Olex2 software. Once you install, this icon will be there in your desktop. This installation you should be done. Next, go to that folder. Here open this RES file, in the right click, then open in Olex2 this software. It will take some time to load. So once it's done, you can see this window. Here, this right hand side, you can get all the detail. What is the space group? This is a data name, sucrose. This is a formula. What is there? Sucrose formula. But this is not exactly correct here. We have to update later. Then lattice parameters are there. A, B, C, alpha, beta, gamma. Then molybdenum, D is the resolution. Then I by sigma, what is the intensity of the data? R int is internal R factor. This should be below 5%. Then full 2 theta, that is near 100%. It should be 100%. All reflections are collected. Then go to here, different buttons are there, home, work, like that. You go to work. Under this again sub menus are there. You go to solve. Here you use SCXRD, that is a program I shared. You can use any of the other software also. Both are equally good. All are equally good. Here click solve. So you can see your structure. This is ball and stick model. Here sucrose has 5-membered ring. This is fructose. Then 6-membered ring is there. This is glucose. Then this is connected by bridging oxygen. You can quickly look at the molecular formula. Go to your sucrose. I think it is known structure, known compound. It's nothing but sugar. This is a molecular formula. Then you can enlarge view. You can uh, see here. Here 5-membered, 6-membered ring and 5-membered ring connected by bridging oxygen. then it has maximum OH and CH2OH groups. Then one oxygen is there in the ring. Similarly, a six-membered ring also has one oxygen. Now go to your Olex and you can see whether all these atoms are identified properly. I can see one atom is not properly identified. Here, this should be CO, because you can click, bring your cursor on the bond. You can see that bond distance is 1.4 something. This can't be oxygen, carbon. You click this atom and make into oxygen. Go to this here toolbox. Here you click whatever corresponding atom you want. I want to convert this into oxygen. In the next step, you go to here, refine, click this one. So this undergoes number of cycle refinement. Here you can see actually how many 10 cycles are there. What is the program we are using? SCXRD. This is a least square refinement. You click this weight, this box should be clicked. You do one more round of refinement. This is now you can remove all this unassigned, that Q peak we call it. Then you roll over the this mouse thing wheel, you can remove them. Then these all atoms are now isotropically refined. It means in the for example oxygen, we treat as oxygen is vibrating in all direction in equal manner, but actually they are not true. So here what you go to under this here two blue spheres are there. One is spherical one. It indicates that we are doing isotropic refinement. You go to this rugby ball kind of icon. Then you are going to do anisotropic refinement. Anisotropic means you are treating thermal motion of the atom so that each atom is vibrating. When it is bonded, in the bonded direction is not able to vibrate, but in all other direction it is vibrating. Now you can see our spherical atom become little anisotropic kind of thing. Next is here all this you see should be green, all this d min, I by sigma, everything. If it is not green means you should take care. So you have to do one more cycle of refinement. So we have done this one. Then remove all Q peaks. Next is we have done all non hydrogen atoms are located. Next you do add hydrogen. You go here and click this one. You can add the hydrogen atoms. Then this dotted line is nothing but hydrogen bond. I think you heard about hydrogen bond with water molecule. Normally it is between hydrogen and oxygen atoms. In this structure also we have lot of hydrogens and lot of oxygens. That is why this type of bondings are there. Here in the next step, here shift is red, goof is red. We have to remove them. You can remove them by using refining more number of cycles. You keep refining until they become green. So now everything is green. I think we are fine. I removed these Q peaks, whatever. So if you include one Q peak, this is the Q1, this unassigned atom. If you bring cursor on that one, you can see what is the number, electron density on that one. It is 0.22. So you need at least one electron to assign any atom. For example, hydrogen is having one electron. So you can say that this is kind of noise or residual electron density in the bonding region. You can ignore them. So this structure is fine. Also you can go to in this label, you can see that maximum peak, that is maximum unassigned peak is 0.2. It means everything is fine. Only now issue is the formula. We know sucrose is C12H22O11, I think. So you have to change it. Go to here, edit, instructions. Here Z you change into 2 because P1 space group has 2. do one more cycle refinement, then automatically your formula is upgraded. This structure is already solved. You can see the R factor, it is 3.21%. Then WR is about 7%. It indicates that we are done this refinement pretty well. This WR2 should be 3 times of the R1. In our case, it is already within the 3 times of R1. Go to tools and info. Here you can see all these indicators, refinement indicator you click. Here you can see R1, WR2, goof, that is goodness of factor, it should be 1. Then you can see number of reflection, that is HKL 13,643. Now how many reflections are above 4I by sigma, that is 3000. Then R sigma, R1, all this information is available here. Next is any bad reflection will be indicated here, that is F observed, F calculated, the difference is more than 10% is considered as bad reflection. Next is you can save this file, go to tools, here go to images, here select bitmap images. Here you can select the type of image you want, JPG or bitmap or PNG format. Normally JPG is good. Go, click on go. Then this figure, whatever screenshot is kind of thing, or this picture is saved. You can move your cursor, whatever orientation want, you can save them and report in the your thesis. Go to your folder. Here you can see sucrose one JPG file is created. Right click and you can open in any program. You can see the final structure. This you should use in your all reports.